So like I said, we're going to be talking about the focus and the directrix of a parabola. And then there are 4 different types of parabolas we're going to be looking at. Ones that open downward, upward, to the left, and to the right. And as you can see, the focus and directrix change location based on this information. The focus always stays inside the quadratic, and the directrix is always outside of the quadratic. So the directrix is this green line right here, and the focus is this green dot. So see how it always stays inside the parabola, and then the directrix is always outside of the parabola. And the distance from the focus to the vertex and the directrix to the vertex are equivalent, and they're known as the letter P. So like I said, there are 4 types. We can either open downward, upward, to the left, or to the right. So let's go ahead and just jump into a problem, and I'll start showing you different things about it as we go through the problems by example. Okay. So the first thing you do when you do one of these problems is you look at your equation, okay? And you determine if the x or the y is squared. So which variable is squared in this equation right here? The x is squared. So if your x is squared, this means that we're either going to open up or we're going to open down. So we can either open up, down, left, or right. If your x is squared, you're going to open up or down. If your y is squared, you're going to open left or right. Now we have to determine if we're going to open up or down. So how you do that is you take whatever the coefficient is and you set that equal to 4p. Yes, it is always 4p that you set it equal to. So whatever that coefficient on the outside is, you're going to set that equal to 4p. And now you're just going to solve for p. Guys that are just getting let in from the lobby, make sure you're logging in with your school email. That's why I have to let you in. If you sign in with your school email, you don't have to be let into my class. So you divide both sides by 4, and we get p is equal to, what's negative 8 divided by 4? Negative 2. So this is what we call our p-value, and this is really important for us in finding different distances on this quadratic. So next thing we're going to determine is the vertex. So the vertex, you have to know this before you can find anything else. So first thing you look at is there anything being added or subtracted from the x that's in parentheses up here? No. So the x coordinate, oops, wrong one. The x coordinate of my vertex is 0. Is there anything being added or subtracted from the y that's in parentheses up here? No. So the vertex is always in the form, it's going to look like this. So if this had a vertex, it would be like x minus 0 squared equals negative 8 times y minus 0. So this would have been, this is the coordinates of your vertex. But since both of them are 0, it's just 0, 0. So that will happen a lot as well. So once you get your vertex, you're going to plot your vertex on your graph.
So what's that formula there for again? So x minus 0.
This is just me showing you that if we had a vertex, this is what if the vertex wasn't 0, 0, this is what the format would look like. But I promise there's a problem later on that has one, so you can kind of see what it looks like. It's just hard to describe when we don't have that scenario right now. So I was just trying to show you what the vertex form of it looks like. So from here, we have to determine the focus and directrix. So before we do that, we have to determine if we decided we go up or down, but we didn't decide which one. So if your p-value is negative, we're going downward. So think of what a downward quadratic looks like. Okay, it goes downward. Now the focus is always going to sit inside of your quadratic. Okay? So is it going to be below the dot, to the left of the dot, to the right of the dot, or above it?
Above.
Below. That's the only way it's going to sit inside, right? And it's always, the distance to the focus is always the absolute value of p from the vertex. So what is the absolute value of p in this case? 2. So it's always 2 units from the vertex. Well, it's not always 2. It's always absolute value of p units. In this case, it's 2. So this is your...
Wait, I have a question.
Sure.
How come you would go negative 2 and not positive?
It's just distance. So the distance of your vertex to your focus is always the absolute value of p. Now that value is going to sit differently depending on where your quadratic is going to fall. So if your quadratic is going downward, the focus is always going to be below the vertex.
Got it.
Okay? So yeah, your focus is going to change based on the way it's situated. So here our focus, the coordinates are 0, -2. And now from here, we have to determine the directrix. So the directrix is always in a spot where it makes the vertex the midpoint, okay? So basically, if you went down to go to the focus, you're going to go up to get the directrix, so 1, 2 units. So it always makes a line where your vertex is the midpoint. And once you plot that, you're going to draw a line through that point.
So the directrix is also the same as P.
It's P distance from the vertex. And then from here, you're going to have to graph our parabola. So to do that, you need to find points on the left and right side because we know it's opening downwards. So we need to find how far it goes out. So how you do this is to find the points. So the points are always going to be 2 times the absolute value of P. So what's the absolute value of P here? 2. What's 2 times 2? 4. Just go ahead and grab notes. Right up there. Okay. So yes, the P value is 2. So 2 times 2 is? So it's 4 units from the focus on both sides. So this distance right here, yeah, the one I left you for on the table, yep. That's always 2p. And then you're just going to plot it. So once you have that, now we're going to go through and list out the rest of these things. So as you guys know, the axis of symmetry is always a line that goes through the quadratic that divides it into 2 equal parts. So this is your axis of symmetry. And in this case, my axis of symmetry's coordinates are x equals 0, because that's this line right here that goes through 0. Now, your directrix and your axis of symmetry are always perpendicular. You guys remember what perpendicular looks like? See how these are always perpendicular to each other. And your directrix is y equals 2 in this case. It's a horizontal line. Now, to find the focal width and the focal length, I'll explain that procedure. So the focal length is the distance from the vertex to the focus. And how many units is that? 2 units. The focal width is always the distance from the 2 points here. And that's also known as, your focal width is also 4 times the absolute value of P, which in this case is 8. So the focal length is the absolute value of P, which is the distance from the vertex to the focus. The focal width is the absolute value of P times 4.
So will they ever be negative?
The distance, the length and width never will be negative because they're distance.
Yeah.
And like I said, this is one of those kind of things that you kind of get more after you just keep seeing it. It's kind of hard to like explain. The very first example is the hardest. I promise it'll get easier as we do more. So do you guys have any questions about this one? Are you able to at least find everything on here that I identified? Okay. So let's try another example. So the next example we're looking at is y squared is equal to 12x. So the first thing you look at is which of the variables is squared? Is it the x or the y? The y is squared. So if the y is squared, that means we're going to open left or right. So if the y is squared instead of the x, you're going to open left or right. Now you can't determine if we're going to open left or right until we know the p-value. To find the p-value, we take whatever that constant is on the outside, and we set that equal to 4p. And yes, you always set it equal to 4p, every time. Once you do that, you divide and you find the value of p, which is 3. So did my p come out to be positive or negative?
Positive.
Positive, which means that we're going to open to the right, according to the chart. So, next thing you determine is the vertex. Since there's nothing being added or subtracted from the y, in parentheses, your vertex is just 0, 0. So unless there's some manipulation of that, you're going to assume the vertex is 0, 0. If you want to know what a manipulation of that looks like, we're going to do the next two examples where it's going to be. So you'll see that in a second. So we'll plot the vertex. And we know that it's opening up to the right, so it's going like this. So your quadratic's going to look like this, which means that your focus is going to sit in here and your directrix is going to look like this, okay, according to your little table. So we need to plot the focus. So the focus, is it going to be to the right, left, up, or down of the vertex?
Right.
To the right. And it's going to be p units from that. So 1, 2, 3 units. And that gives me the coordinates 3, 0. Once you find the focus, you need to find the points on each side. So you take 2 times p, and that's going to be your 2 points. So 2 times absolute value of p is 6. So my points are going to be 6 units down and 6 units up.
Wait, so this is for your focus?
From your focus, you have to find the points, and you use the focus, and then you go out 2 p units. So this is always 2 times the absolute value of p. 2 times the absolute value of p is that distance. So to go from your focus, you go down and up, or left and right, depending on the orientation of your quadratic. 2 times the absolute value of p units. So that's 6. Everybody get why it's 6 there and there. So once you get that, next thing we'll graph is the axis of symmetry. So this is a little bit different than what you're used to. You're used to the axis of symmetry being vertical, but this time your axis of symmetry is actually horizontal, because see how it has to go this way now, because that's the way you're going to cut your quadratic into 2 equal parts. Now horizontal lines, the equation of horizontal lines are always y equals. And what y coordinate does this line go through? 0. Now to determine your directrix, however many units you go from the vertex to the focus is however many units you're going to go the other direction to your directrix. So how many units did I go from the vertex to the focus? 3. So you're going to go 3 the other way. You're going to plot that point, and you're going to draw a line. And that line is going to be the directrix. Now, the directrix and the axis of symmetry are always perpendicular. So if you don't get 2 perpendicular lines that create a right angle right here, you did something wrong. And your directrix is going to be x equals -3. Now, another important note, if your axis of symmetry is y equals something, your directrix is going to be x equals something. Because one's got to be horizontal, one's got to be vertical. It's going to be flipped based on the orientation of your quadratic, but they're always going to be, one's going to be y equals, one's going to be x equals. They're never both going to be x, they're never both going to be y. They're always going to be one and the other. Could be flipped, but keep that in mind. One's going to be horizontal, one's going to be vertical. Now we're going to determine the focal length and the focal width. Now the focal length is always just the absolute value of p. Okay, and what is that? 3. So the focal length is the distance from the vertex to the focus, which is absolute value of p. Now the focal width is always 4 times the absolute value of p. So the absolute value of 3 is 3. 3 times 4 is 12. The focal width is basically this whole distance right here. So if you want to know what it actually is, it's this distance here from one point to the next, and that would be 12. And that's the mathematical way to get it. So do you guys feel better after seeing the second example a little bit?
Will the focal width always be the number with the variable that's not squared?
The focal width will always be whatever, if you take p and take the absolute value of it and multiply it by 4. It's always going to be whatever that is. Okay? Any other questions? Alright, let's try example number 3. Oh look, this one's going to have a different vertex. Okay. So for example number 3, first thing we look at is which variable is squared here, the x or the y? The y is squared, which means we're going to either be going left or right. We don't know yet because we got to find p. Now this is where it's different. Your vertex is not 0, 0 here, it's shifted. So how you determine the vertex from the equation is you look at what is being added or subtracted from the x, which is negative 3. It's always going to be the opposite in the vertex, which makes it a positive 3. For the y coordinate, you look at what's being added or subtracted from the y. 2. Negative 2, which means that the vertex here is 2. So it's always the opposite signs. So if you want to put a little note for that.
You don't have to square it.
Nope. It's just opposite signs of whatever is being added or subtracted from the x and then the y. Now if one of them didn't have anything subtracted, that would just make that coordinate 0 like we'd been doing on the last problems. So like if there isn't anything added or subtracted, it's just a 0. Like we did on the last one.
If it was y plus 2, would it be negative 2?
Correct. Yep, it's always the opposite. Good question. So now that we have the vertex, we need to find the p-value, right? So to find the p-value, you always take whatever this constant is on the outside. And you take that constant and you always set it equal to 4p. Okay, every time it's 4p. Once you set equal to 4p, you divide both sides by 4, which gives me a p-value of what? Negative 1. Does this mean we're going to open left or right?
Left.
Left. So now we're going to plot our vertex. So it's 3 units, 1, 2, 3, and then up 2. So this is my vertex. From here, we need to find the focus. So let's think about what a left opening quadratic looks like. This is my vertex, which means that my focus is going to be to the left, right, up, or down?
Left.
To the left. If you open left, it's going to be to the left. It's always whatever direction we open or whatnot.
Why is it 3?
It's not. I don't know why I did that. I was thinking of the last problem. Yeah, it's only going to be 1 this time. So the distance from the focus to the vertex is always going to be the absolute value of p. In this case, that is, yep, just 1. So it's 1 unit over. So the coordinates of my focus are 2, 2. And now we need to determine the points on each side. So from the focus, you're going to go up and down this time because it's to the side. So what's the absolute value of p? 1. What's 1 times 2?
2.
So it's going to be 2 units up, 2 units down. Once you have that, you can plot it. So now we need to determine the axis of symmetry and the directrix. So my axis of symmetry is horizontal, because that's what cuts my quadratic in half. And in this case, the equation for my axis of symmetry is going to be y equals 2, right? That means my directrix is going to be x equals something.
Wouldn't it be negative 2?
my directrix?
No, you access the symmetry.
No, because see how it's above the x-axis? It's at y equals 2.
Oh yeah, I graphed it negative.
Oh, okay. Does that make more sense now?
Yeah.
Okay. So then, now we need to get our directrix. So our directrix is always however many units we went from the vertex to the focus. So that's 1 unit. Which means we go this way. Which gives me 4. And now we're gonna, oh, go ahead.
So how did you get 2, 2 for your focus?
Your focus is always p units from your vertex. So I just went over p units. And it's, if we're going to the left, it's p units to the left. So 1 unit from the vertex.
And then how'd you get 4 for the
The directrix is always 1 unit from the vertex, the other direction, from the focus.
But like, how'd you get 4? Oh, is it because of the...
Yes, it's on the other side. Yeah, Giovanna?
You said it's always 1 unit.
It's always p units. So in this case, p is 1. So this distance right here is determined by p. So the distance from the vertex to the focus and directrix is always the absolute value of whatever p is. Okay? It's just hard. This graph's very small, so it's like hard for me to label stuff because everything's smushed. Like on the last ones, I was labeling p and whatnot, but on this one, it's hard to label.
So the focus is, one more time, it's
P units, absolute value of p units from the vertex.
absolute value of p units from the vertex. Okay.
Yep, so absolute value of p is the distance from the vertex and the directrix. So vertex is always in the middle. Okay, that's the vertex.
Mm-hmm.
And the focus is always whatever we determine our direction of our quadratic is the same as direction of our focus. Our focus is to the left, we determine.
Mm-hmm.
That means the directrix is the other direction, to the right. It's always the same number of units, which is absolute value of p.
Okay.
Make more sense?
Yeah, so wouldn't it be 1, 1?
No. 1 unit. 1 unit over gives me 2, 2.
1. Oh, okay, you're talking about the actual point, okay.
Yes, the actual point. We don't, just because it's 1, the p is 1, doesn't mean the coordinate's going to be 1.
Yeah.
Okay? So now we're going to talk about the focal length and the focal width. So the focal length is always the absolute value of p, which is
1.
the focal width is always 4 times the absolute value of p, which is 4. And then to remind you guys, this is the focal width right here. This is the focal length right there. That's what it is on the graph. Yeah, so on the last few examples, all the ones we've been doing, we were at the center.
Mm-hmm.
So everything we did was like the same as the p. So I think that's what was confusing about this one. Do we have any questions on this one? Next question. So this is example 4. First thing we look at is which variable is squared here? X. So this means we're going up or down? Yeah, we're going to go up. So now we have to determine the vertex. So the vertex, we look at the x coordinate. Okay, it's positive, so in the vertex it's going to be?
Negative.
Good. We look at the what's added or subtracted from the y. It's positive, so down here it's going to be? Negative. Very good. So we're going to go over 1 unit and down 2 units. That's our vertex. Now in order to do anything else, we need to find our p-value. So you take that coefficient and you set it equal to 4p. When we solve for p here, we get 4, which means that we're opening upward because our p is positive. So if we're opening upward, here's the little mini sketch. That means our focus is somewhere in here, and then our directrix is down here. So on the front of the notes, like see how I gave you those 4 little diagrams of what they look like in the 4 scenarios? That's always kind of helpful to double check if your focus and your directrix are in the correct position. So from here, we're going to determine all of the other stuff. So if we have to go up, that means we have to go up for our focus as well. So how many units up am I going for my focus this time?
4.
Good, 4 units. And when I go up 4 units, yeah, I'll have to in a second, yes. So my focus in this case is going to be at -1, comma 2. That's the coordinates of it. So now we can do our directrix. It doesn't matter what order you go in for some of this stuff. The directrix is always, same amount of units in the opposite direction. So 4 units down. This time, is it a horizontal or vertical line? It's horizontal. Oh my gosh, I'm lagging. I'll draw that when I can draw it better. Hang on. That's gonna look bad. There we go. This is my directrix. So now we need to find the points on each side. So the distance to find the points, you always go 2 times the absolute value of p on each side. So what's the absolute value of p?
4.
What's 4 times 2?
8.
So 8 units this way. 1, hang on, my mistake. From the focus. That's not the focus. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now we graph it. Remember that that's a pretty bad graph, but you get the idea. Remember that your directrix always sits outside of your quadratic or your parabola, and your focus always sits inside. The distance from your points to your focus is always 2 times the absolute value of p. 2 times the absolute value of p. Focal length is right here. Focal length is always the absolute value of p, which is
4.
focal width is always 4 times the absolute value of p, which is 16. And now our axis of symmetry. Wait, are you confused? For which one? Oh, yeah, that's each separate distance right here. So this distance is 2 times the absolute value of p, which is 8. And this distance is 2 times the absolute value, which is 8. The focal width is this whole length right here. So when you add them together, you get 16. Does that make sense? Okay. So now our axis of symmetry always goes through the middle of the vertex and goes through, the whole thing. And my axis of symmetry this time is x equals -1. Which means my directrix has to be y equals something, because it's horizontal, and it's y equals -6, right? So horizontal lines are always y equals whatever point it goes through. Vertical lines are always x equals whatever it goes through. Make sense? Okay. Any questions so far? You guys starting to get the hang of it now that you've seen them all? All right. We got a few more things to do. Like I said, we're not doing all of the notes on this, so now we're going to write equations. So this is actually easier than the graphing, in my opinion. So hang on a second. Okay. So in order to write an equation, you need to know what the general form for the equations are. So for the first one, for vertical, it's x, parentheses x minus h squared is equal to 4p times y minus k. And for a horizontal graph that opens left or right, the equation is y minus k squared equals 4p times x minus h. So those are your two general formulas. So a few things to note here that's important that could throw students off. Sometimes this is going to be written backwards, okay? You know how like x equals 4 and 4 equals x are the same exact thing? That's the same thing for equations like this as well. So if they write it this way, you're still looking at which one's squared, because the one that's squared determines things, not which side the squared is on. So I just want to make that clear. Okay, so now we're going to do our example. So for each example, the first thing you do is you determine which direction it's opening. Yep, this one's opening upward, okay? Next thing you're going to determine is what's the coordinate of the vertex. I think it's 0, 5, or 6. 0, 5. Yep. 0, 5. 1, 2. What? Does it say? Just the V means the vertex.
Oh, that's the vertex?
Yeah, this point right here is the vertex. I think the V, the way that they tried to write it on here, it was like trying to label that point. So your point is the vertex. So now we need to find P. Now P we know to be the distance from the vertex to the focus is P, right? So what's that distance? 2. Now, this is positive because it opens upward, but what if this were downward? It would have been -2. So if it's downward or to the left, your P is negative. If it's upward and to the right, it's positive. So now that you know V and P, V is always H comma K, and P is 2. So all you have to do now is plug it in. So this is x minus 0 squared equals 4 times P. Oh, I know P. I don't know why I wrote P in. Sorry. 2 times P times y minus 5. So I just simplify this and I get x squared, because x minus 0 is just x. X squared equals 8 times y minus 5. Now, some of these questions are going to ask you to rearrange this to get y by itself. I'm not going to do that right now. I'm not going to ask you to do that for the homework. I'm just going to, leaving it like this is fine. I think you guys at this point know how to get this to get y by itself. So, just leave it at that. You can get y by itself. Does anybody want to see me get y by itself on this? Okay.
That's not an answer.
This is fine for me on the homework. I'm just saying, if in the future you're asked a question, they want you to get y by itself, because that's usually the form you see an equation in, you have to know how to move everything around.
You just distribute and then like square root everything, right?
I would divide everything by the 8 and then add the 5 over. That'd be the easiest way to do it. So, I'm going to do the U-try because I want you to try one that gives you the directrix in the vertex, because you haven't seen that yet. So what's the coordinate of my vertex in this case? Good. Now, is this quadratic opening up, down, left, or right? Which means my p-value is going to be what? Negative something, right? Now, we know that the distance from the vertex to the directrix is p. The distance from the vertex to the focus is p. The distance from the vertex to the directrix is also p. So how many units is that? Yeah, 10, you're right. -10 is your p. Everybody understand why the p is negative this time? Because it's opening downward. So now all you would do is plug this into your equation and then just simplify it. So this would be x minus a -5 squared, -4, my bad.
Would that just be x plus 4 then?
Yes. Which would be 4 times -10 times y plus 5. That should be x plus 4 squared equals. Oh, it's because it would have been a minus -5.
Wouldn't the x minus -4 squared also be +4?
It is +4. I just skipped that step the second time around. See how it becomes a positive? Yeah, because the formula has a negative sign in it, so it's always going to change the sign of the two. So in your formula, your vertex is always going to change signs because both of the h and k in the formula both have a negative sign in front of it.
Can you solve for y one time?
Sure. So I'll solve for y on this one so you can see it.
Are they gonna use these, like, solve for y on the test or the quiz?
Mm-mm. So we divide both sides by -40, which is going to give me x squared, or x plus 4 squared over -40 is equal to y plus 5. And then I would just subtract 5 on both sides and get y equals x plus 4 squared over -40 minus 5. So the reason I don't want to get too much into solving for y is because if you have a multiple choice question or anything like that, things are going to be represented totally, they can represent things however they want. So you have to be comfortable with manipulating and understanding something like, like you have to sometimes move the equation around at this stage. Like, for example, if I give you something like this, you have to know that's the same thing as this. So it's kind of like a more complicated version of that. So if you ever get to a multiple choice question and your answer isn't shown, it might just be a matter of you having to move some stuff around. Like how 0.5 is the same thing as 1/2. So that's kind of the best thing I can say about that. As for the homework on this lesson, let me stop my video.